Hello, my name is Andres. I'm the current president of Antec.
The beginning of this season was uncertain. Health concerns in our country made it impossible for us to return back to campus. With members working remotely from all over the country, we decided to set our approaches to continue improving the previously designed systems in simulation and focus on developing the areas where knowledge has been lost, such as state estimation, perception, and finger localization. In mid-February, after 2 years of lockdown, we finally returned to presentiality, and from then on our focus shifted to physically implementing all the systems, a first for us in this competition. Although challenging, I am pleased to say that several milestones were achieved since we're back in our lab. We now present our competition strategy for this season. Based on this season's developments, the following tasks were selected to be attempted in simulations with our real-life developments on the works for future implementation. Choose your side, make the grade, collecting beans, capture a smash, and survive the showdown.
Hi, my name is Sofia and I'm in the software team.
Our new exploration system was designed to provide optimal performance over a large number of maps. Not only was a new search algorithm implemented, but also the robot now understands its surroundings and reacts to new changes.
Hello, my name is Kevin and I am part of software team.
We begin working on a new strategy that involves separating groups of point clouds with similar characteristics and assigning them to the appropriate clusters. As a result, we will obtain exploration plans with a high probability of finding a challenge.
Hello, my name is Edison. I am part of the software team.
We developed a state machine-based system to complete the task with the exploration zones previously mentioned. Particularly in Choose Your Side, we implemented a vision system detection to recognize both G-man and bootlegger images and make a decision to pass to the selected target. In case we don't recognize any image, the UUV runs the aforementioned search algorithm inspired by clustering methods, such as K-means, which is an unsupervised machine learning algorithm, and this is the quickest and most effective in grouping data points into categories.
Hello, my name is Sebastian and I'm vice president of Antec.
Last year, we trained a Jolly network which gave us great results but left areas of opportunity when the submarine had to obtain pertinent information from the props, such as the angle of inclination. For this year, it was deemed necessary to give focus to the development of a new perception system, not only capable of identifying the different props present in the competition, but also capable of giving us context on the shape from the identified object. For this reason, the new approach for a real-time instance segmentation was a JOLAC architecture, which could give us a mask for each object identified. Each of them could be further analyzed to get properties needed for their tasks. The newly trained vision system is achieved using the SET2i, which is a stereo camera allowing to obtain the depth of the objects.
To accomplish the make the grade task, the UUV uses a downward camera to identify the path marker direction. Then, the craft proceeds to explore the closest point cloud cluster arrangement generated by the K-means method. Using the prior mentioned work in perception, our vision systems recognize both voice and decide which one should be approached.
Now, speaking about vehicle modeling and control, the dynamic model used for simulation and custom control design was enhanced, as we previously had a 4 degrees of freedom model, but to develop a more realistic simulation, the model was improved to a 6 degrees of freedom one. Furthermore, the existing 4 degrees of freedom PID controller was replaced by a 6 degrees of freedom adaptive sliding mode control, which presents a better performance when the system is subject to external disturbances, such as water currents, and also when there are uncertain parameters. Our UUV platform was redesigned. It still preserves a 6 thruster configuration, but now full activation is enabled by tilting the thrusters a little bit, although motion in search is still prioritized. This is helpful as it is now easier to stabilize the vehicle in roll and pitch, and doesn't affect overall performance as most of the maneuvers are thought to be performed in search.
Following the generated cluster for exploration, the submarine moves toward the next one. The distance to each identified cluster is calculated using an Euclidean distance function, with measured distance between data points. Thus, it prevents the combination of clusters by deciding which data points belong to the same cluster. Once the submarine reaches the beam zone, it positions over them and proceeds to deploy a path marker.
After 3 years, we were able to achieve results with the hydrophone-related tasks. We had 3 hydrophone arrays. We are capable of implementing the algorithm direction of arrival. which correlates the different signals to obtain the phase difference and help us determine the horizontal angle between the submarine and the bindery. We decided to buy an analog device running a dedicated PCB for filtering and amplification of small signals, which turned to be way better than our custom designs.
Hi, I'm Adrian and I'm in the area of perception.
Thanks to our finger localization and vision exploration systems, we can use both methods to reach the shooting zone. Once the UUV identifies the prompt, it decides which one to shoot. Using shape detection, a waypoint is generated in the center of each opening, which helps the UUV positioning itself and the target.
As the submarine operates in a subaquatic environment, localization techniques such as commercial GPS do not work. Hence, it requires an alternative location method that satisfies the technical requirements to obtain the suitable observability.
Hello, my name is Emiliano Prado and I work on the localization team.
This led us to work with estimation methods that work with actual and previous states in order to provide approximations. In our case, for the vehicle's position and velocity. Thus, we designed a Kalman filter that uses the information measured by an EMU, a barometer, and a DFL.
Hi, I'm Clau, and I'm part of this software team. Additionally, the new exploration method takes advantage of the Kalman filter to perform a more precise estimation of the identified clusters.
For the last task, the submarine shifts its route towards the center of the octagon by tracking the signals of the acoustic finger. At the moment, the UV is below the octagon. It moves upwards to reach the surface to earn some points.
Hello, my name is Ian and I am part of the electronics team.
As we were building some parts of the UUV at the beginning of this year, we saw a lot of opportunities regarding the electronic components. First, we worked with the mechanics team to design a rack that fits the 8-inch cylindrical enclosure that houses the Jetson set camera and custom PCBs in different levels. Both the power distribution board and the motor controller board that were designed for the RoboBoat competition also work for this vehicle, as some aspects of both systems are similar.
My name is Diego and I am part of mechanics team.
With the aim of developing a modular platform, our submarine underwent a redesign which prioritizes space and flexibility to add future components or even change its current distribution. An 8-inch cylinder replaced the old steel 6-inch enclosure that encompassed the hardware. Also, an extra rib was added to provide structural support as well as more space to relocate internal elements.
Structural test using SolidWorks to prove minimal deformation and infinite life cycle of the ribs. Thanks to the use of nylon as main construction material, we achieved a weight of 22 kilograms, which may award us extra points in the competition.